And welcome back. In this video, we're going to talk about separation of variables. This is a key strategy. And basically what this strategy does is it lets you find one of these solutions, a solution that makes the two sides of the equation equal. It lets you find a solution, y equals f of x, for any differential equation that is separable. So where you can separate the x and the y terms. And there are certainly differential equations out there that are not separable, but in this class we're only going to be dealing with ones that are separable, where you can get the x terms and the y terms on different sides. Okay, so let's walk through this. So let's go ahead now and find a general solution to the differential equation. Dy dx equals 4xy squared. Okay, so here's the steps that we're going to walk through. And in broad strokes, what we're going to be doing is following the same three-step process. So we're going to separate the x's and the y's, and then we're going to integrate both sides. And then the final step is we want to have an equation for y, so we're going to solve for y equals. Okay, now when we're separating the x and the y terms, one tip I want to give you is you're only going to be able to multiply and divide. If you try and add and subtract, you're going to mix up x's and dy's and y's and dx's. It's going to be impossible. You can only multiply and divide terms to both sides. Okay, so what that's going to look like, we're going to try and get kind of the x's on the right and the y's on the left. So it seems weird, but we're going to try and break up this fraction here by multiplying a dx on both sides. So that cancels. So we'll get dy equals 4xy squared dx. Now I want to get the y's on this side, so I'm going to divide both sides by a y squared. So I'm going to get dy over y squared equals 4x dx. Great. So at this point, we got all the y's on one side, we got all the x's on the other side. Now, well, what does this look like? These both look like integrals. So if I want to get rid of the x's and the y's and just be able to solve for, or the dx and dy's, just be able to solve for y, I'm going to integrate both sides. So I'm going to slap both sides here with an integral stick. Now, both these integrals should be pretty straightforward. You're integrating y to the -2, so that'll be negative y to the -1, so negative 1 over y. The right side integral is 2x squared. Now what I'm going to do is I'm only going to put 1 plus c. Now, I mean, technically, I guess when you do integrals, you should put a plus c on two different sides, but they're different, right? And if you have one constant, you could call this a constant, this another constant, it's still a constant, right? If you just subtract one, you just have one constant minus another, this is still a constant. So what we're going to do is we're just going to put 1 plus c, and we're going to put it on the x side. You know, we know in our minds that both integrals lead to plus c. What we're doing is we're just combining them onto one side like that. Okay, so my goal at this point was to solve for y equals. So we're going to get y by itself. And this is just going to be where we're going to use a bunch of kind of cute algebraic tricks. So let's see, we'll multiply the y to the other side. So I'll get rid of the fraction. That'll be my first step here. And then my goal is to solve for the y, so I'll divide by this whole shebang. So y is -1 divided by 2x squared plus c. Okay, and this is what's called our general solution. And any general solution, by the way, has a plus c in it. We're going to later talk about particular solutions without a plus c. But this general solution right here means that anything that's in this form, -1 over 2x squared plus c, anything in that form makes this differential equation true. If you were to plug it in, the derivative of that function is equal to 4x times the original function squared. Okay, and that's what we mean by finding a solution. Again, the key on this is 3 steps. We separate the variables, so it's called separation of variables. We integrate both sides, and then we get that y by itself and solve. Those are the steps we take. We separate, we integrate, we solve. Let's look at a couple more examples. So in this next example, let's say we have dy dx equals 3x squared plus the cosine of x, all divided by y. And again, we're going to find the general solution. So if you want, go ahead and pause the video now and try this problem on your own, and we'll compare work in just a minute. Okay, so hopefully you've done that on your own. So we can separate, we can integrate, we can solve, and then we can kind of compare answers here. So we have y dy equals 3x squared plus cosine of x times dx. Okay, now again, we're kind of multiplying the dx to both sides to cancel those, and then we'll multiply the y to both sides to cancel those out. So the x's cancel and the y's cancel. So that's how we get the dx and the x terms on one side, the y and the dy on the other. And this whole thing's multiplied by dx, of course. Okay, so let's integrate both sides. So we're going to get y squared over 2. This integral will be x cubed. Derivative of sine is positive cosine, so plus sine of x. Okay, now our goal again, we separated, we integrated, let's solve for y. We're going to get rid of the 2 first. So y squared will multiply everybody by 2. Y squared is 2x cubed plus 2 sine x plus 2 times c. Now, you might not be sure, what do we do with the squared? Well, obviously, or maybe not obviously, but the opposite of a squared is the square root. But make sure that you remember the plus or minus. Very important. So y is plus or minus square root 2x cubed plus 2 sine of x plus 2c. Okay, so just as a reminder, this is our general solution, and it means anything that's in this form is going to be a solution to this differential equation. The derivative of that equation is 3x squared plus cosine x divided by the original equation. That's how this works. Okay, that's what we're finding. Let's do one more example here, and then we'll talk about a trick. So suppose I tell you now dy dx equals cosine of 3x divided by e to the y. And we're going to see kind of some, actually, let's make this a sine 3x. Let's make our life a little more interesting. Let's try and do this one, and we're going to see some nasty integrals and some interesting algebra here. Okay, so let's see. We'll multiply the dx on both sides. That's my first one. So I'm going to get dy equals sine of 3x over e to the y times dx. We want to multiply the e to the y now on both sides. So let's see. So we're going to get e to the y dy equals sine of 3x times a dx. Now, when I slap this guy with my integral stick, the left side, of course, is very straightforward. On the right side, we got to do a u sub. We want to be careful here. So u equals 3x. The derivative is a 3 dx. So we'll put a 3 here and a 1/3 in front. So that becomes a 1/3 integral sine of u du. So when I integrate that, it's 1/3. Okay, derivative of cosine is negative sine, so it's negative cosine of u plus c. Okay, so we're going to get e to the y equals negative 1/3 cosine of 3x plus some constant c. And now you're wondering, okay, how can I solve for y? How can I get the y by itself? Well, y is inside of an e to the y. So what's the opposite of e? It's ln. So if I want to get the e by itself, I take the natural log of both sides. So I get, cancel, y equals natural log of negative 1/3 cosine of 3x plus c. Okay, so that's how you find a general solution. That's how we kind of solve for the y. And that's the main thing. I think the key is just to remember anytime you're doing these, you separate, you integrate, you solve. Those are the 3 steps that you want to be walking through as you do this. Okay, finally, one more trick to end this video is if you have something like this, say dy dx equals 3x squared minus x squared times y, you might be kind of flummoxed on this because you're like, well, we have like a y here, but not on the other one, and we can't add or subtract. And you're right, we can't add or subtract. But what I want to remind you to do is to factor first. So if you get something like this, factor out an x squared on the right side. And then you'll see, oh, if I factor an x squared, then I have a 3 minus y. And then I can divide 3 minus y, multiply the dx, and so forth. Okay, so those are general solutions, guys. Thanks for watching. And make sure you bring questions in class. I'll see you soon.